Hello everyone. Today I'm going to give a demo of heart disease prediction using retinal images. So in this project, we have collected the images of retinal images, and training is done through three algorithms: depth-wise, convolutional 2D, and subtable convolution neural network. And testing is done through the GUI. So we go for the code. Let type ideally. Click on open. File. Open. Yes, trying to click on it. So this is the to be separable convolution neural network. So which we have collect these are the libraries we use for to train the model, and this libraries is used for to load the files, and this for is for to convert into the array form, and this globe is used for to list all the files, and this target is used for file categories is there inside the dataset folder. And in this load dataset function, we are coding the files, and after loading, convert into the each image into the array form, and split the dataset into train and test. And after this, we will print the whole number of total categories and total images and train images and test images using print. And after this, each image is converted into Python image library. After Python image library, it will convert into 3D tensor. Once it is converted into 3D tensor, it will convert into 4D tensor by using x is equals to 0. This part is used for to display the graph. In the upper left, you can mention the title, trained and validation. Along x-axis effort, along y-axis the. So these are the libraries used to define the separable convolution neural network algorithm. So this is the defining the model, and here we are using filter 60, convolutional size 3 cross 3, and activation rate will be used. So whenever we get the input in the form of negative values, it will take it as zeros, all negative values, and if there is remains positive, it will remain as unchanged. For that purpose, we will use ReLU. It is rectilinear image. Flatten is used for to convert two-dimensional into one-dimensional, and softmax is used for classifying purpose, and model.compile is used for to display the accuracy in the command prompt. And these are the accuracy parameters. We in order to increase the accuracy, we use these parameters in the model.compile. After compiling, select the model. Once it is hit, just will save model.save supplemental CNN. This is the file categories. So the adaptation that time for the civil continue. So this was completed after 100 iterations. So we can mention above 50. This we can mention above question. Thank you. After 10 iterations, the process will be stopped. So after we will get the graph and check for convolutional 2D algorithms. Click on run on it. So in this project, we are training three algorithms: convolutional 2D, subproposition, and depth-wise convolutional neural network. So this is the training. The process is continued still 50 iterations. Mention history. Click on run on it. Here you can mention epoch, time, con run on it. So after completion of 5 iterations, it will get the graph. So you can check for depth wise. So we have used depth wise algorithm to train a dataset of retinal images. Click on random. So you will get the model summary. Click and iterations. Processing to continue. Enter accuracy in graph of validation evidence. Lot of. So now we go for the prediction part. So prediction is done through the GUI, where this library is used for to create the GUI. So here we have loaded this model, and based on it, it will predict the output on the model. So you can give the here you can give the username, password, click on login. You can upload the image in the dataset. Close is not default. Click on the username, person, upload the image from the dataset. So in this, we have to mention the tensor flow with the Keras model. Tensor flow, Keras, save and run the model. Enter username, password, account login. So you get once you upload the image, prediction, and also based on the prediction of retinal images, you will get the diabetes, disease of diabetes. Now we can check for another entity. See, predicted out.